Hi, I'm Stu from HiveMind Automation and welcome back to the Hive. In this DIY project video, we'll be doing an introduction to ESPHome with this ESP01S relay board. We'll start by taking a look at the ESP01S relay board. We'll need to install ESPHome into Home Assistant and set it up. And then we'll flash the controller on this board with ESPHome and go through a little bit of code to set the controller up to trigger the relay. So while I roll the intro, why don't you take a moment to subscribe? And if you hit the bell icon, you'll get notified when I release new videos, and that's normally every week. While you're at it, if you like what I do here and you want to support the channel, there's affiliate links in the video description to a bunch of home automation gadgets that I've reviewed in the past. And there's other ways to support the channel as well, like signing up for NordVPN using my affiliate link, or supporting the channel directly through my Buy Me a Coffee link. With all of that out of the way, let's get started. So the motivation for this project is actually a few different project ideas that I've had. The main one is actually this Millennium Falcon lamp that is behind me. It's USB powered and I've struggled to find any pre-made remote USB switches. The obvious solution then is to use a relay to then switch the USB power. And I found these ESP01S boards on eBay and I grabbed two of them for $25 shipped from the UK, but I have included an affiliate link in the video description to AliExpress where you can get these boards for $2.99 each. The affiliate links don't cost you any extra, but I do get a kickback from the seller and that helps support the channel. So if you want to create your own project using one of these ESP01S relay boards, check out the link in the video description to pick some up for yourself for $2.99 US per board. One of the other ideas I had for one of these relay boards is to use the relay to trigger the garage door opener to open or close the garage door. So I might explore that in a future video. Let's take a look around the board quickly. So over on my B camera, we'll take a closer look. There's this ESP01S board that we can detach from the relay daughter board here. And we've got these 8 pins on the bottom, the 2x4 row. If we take a closer look, we see we've got 3v3, RX, TX, ground. There's IO0 and IO2 listed there, and a reset and an EN pin there. We'll pop that aside and we'll take a look at the relay board. And looking at the relay board, if you are keen-eyed, you might notice a little voltage regulator in here, and that will regulate the 5 volts that we input to this down to 3.3 volts for the ESP01 board. We've got the header for the ESP01 board. There's a reset switch on the side here. There's some screw down terminals for the power supply. This is a 5-volt power supply. We'll see that in a minute. And screw down terminals for the relay itself. Obviously, we've got the relay here. And you can see that the relay, you might be able to make that out on the camera. The relay is rated to 10 amps at 250 volts AC, 10 amps at 125 volts AC, 10 amps at 30 volts DC, or 10 amps at 28 volts DC. This is a 3RD05 VDC SL-C relay for anyone who is interested. The 05 VDC just means that it is a 5-volt trigger voltage. If we take a look at the bottom of the board, we can see the pins for the screw down terminals. We've got 5 volts and ground on the power supply there. We've got normally closed, common, and normally open for the relay, and that just means that the common is what we're going to switch either to the normally closed or normally open terminal when we energize the relays. When we're not energizing the relay, normally closed is going to be connected to common. When we do energize the relay, normally open is going to be connected to the relay. So what I've done in order to power this board, I've got this butchered USB cable. One end is just USB, and the other end is just the red and black wires from the USB cable. I've trimmed off the white and green wires. I'm going to hook these up to the relay board here. Now, if like me, you were going to be switching the USB as well as putting the 5 volts into the supply line, you would then also put a loop into there as well. And you would then put that into your common port on the relay there. And the other end of your USB cable would also have the ground into the power supply port here. So the ground would be bonded together on both the supply side and the load side. Okay, so I've just put the positive, the 5 volts positive into the 5 volts positive on the power supply, and I've also looped that out into the common on the relay as well. So that means that we're going to be able to both supply power to and switch the load via this USB. If we were switching something like 24 volts DC or even 240 volts AC, we would put the active lead from that into the common on our relay and then either use the normally closed or normally open side of the relay, depending on whether we wanted the device to be on when the relay is not powered or off when the relay is not powered. And we'll take a look at how we can set that up in the code a little bit later on. What we're also going to need to do is put some firmware onto the ESP01S. In order to do that, I've dug out my USB serial programmer that we've used in order to flash Tasmoda onto some 2U-based devices in the past. And I've made up a little wiring harness to plug that into the ESP01S here. So we want the red to go to the 3V3 and the orange to the RX. So we will plug that in here. Now, when we're flashing this, when we first plug it into power, we also want to have GPIO 0 connected to ground, which I've got there as well, and that just puts it into flashing mode. So before we plug the USB programmer into power and our computer, I'm going to need to install an add-on into Home Assistant so that I can, in fact, flash this board with the firmware that we need. So I'm going to head over to Home Assistant here. I'm going to open up Settings, and I'm going to open up Add-ons, and I'm going to click on the add-on store here, and I'm looking for ESPHome, which is in the ESPHome repository, and I'm going to click this ESPHome and install it here. This will take a couple of moments to install the ESPHome add-on, and once it has done that, we will set it up for use. Okay, so ESPHome is installed. It's already got start on boot. I'm going to turn on all of the other switches there so that it's shown in the sidebar as well here. And there's nothing else to configure. I'm just going to click on Start. And it's started up the add-on, so we are now good to go. I'll click on the ESPHome menu item on the left-hand side, and it says, "Welcome to ESPHome." It looks like you don't have any devices. First things first, I'm going to need to configure some secrets in here so that we know what our Wi-Fi SSID and password are. So we're going to click on secrets in the top right-hand corner, and you'll see we've got Wi-Fi SSID and Wi-Fi password, and they both say replace me. So I'm going to put in Hive Mind IoT in the Wi-Fi SSID, and I'll replace the Wi-Fi password with the password for that SSID. And I'll click Save and Close, and we've saved the secrets.yaml file there. Now that we've got the secrets.yaml file set up, we can go ahead and start configuring our device. Now, before we get too far down the rabbit hole, it's worth mentioning that if you are not connected to your Home Assistant instance over HTTPS, then you will not be able to follow along with the next few steps while we flash. You'll need to plug your USB serial programmer into the machine that's running your ESPHome instance dashboard. In order to deal with that, I've got ESPHome set up on my production instance of Home Assistant, and you can see we've already got one device in there. Now I've plugged my USB serial programmer into my computer here, and I'm just going to unplug the GPIO 0 ground lead that I also had on there as well. And we're going to click on New Device in the bottom right hand corner, and I'm going to call this one Test. And it says ESPHome will now create your configuration. Connect it with a USB cable with your computer and click on Connect. We'll click Connect, and we're going to select USB serial in the top left corner here, and that's the same as we would see on any page that enables ESP tools. So for example, when we were installing WLED in previous videos, we could click Connect here, and it's going to connect to the board, and hopefully we'll then flash the board. It's had some trouble there, and it's telling us to try resetting or holding the boot button while selecting your serial port, and still it starts preparing the installation. So I'm just going to, so we'll reconnect GPIO 0 to ground, disconnect, and reconnect the board. We'll make sure all of our pins are connected properly. I note that the orange wire is coming out a bit there, which is connected to RX. I'll just try that again. We'll hit connect, select USB serial and hit connect. It's trying to connect, preparing the installation, and it's working this time. So it did take me a few goes to get that to connect. It's worth mentioning that there are dedicated programmers for these units, and I think I might be purchasing a few of those, because honestly that was a bit more challenging than I would have liked. So this is going to take a couple of minutes to install ESPHome onto the board. Once that's done, we'll be able to start looking at the code to manage the board. Okay, so all up, that took around about 5 minutes. The configuration's created. We can now click close on there, and we've got our test ESPHome, and it shows us that it is online. What we can actually do now is disconnect the ESP01S from our USB serial controller, and I'm going to plug it back into the relay board here. And I'm going to plug the relay board into power. So back over in Home Assistant, we can click on Edit underneath Test, and we've got the first half of the configuration, but this is really not doing a whole lot for us. What we need to do is create some configuration underneath this captive portal. The great news here is that the ESP01S one-channel relay board has a page dedicated on the ESPHome-devices.com website. And if we scroll through here, we can see that we've got some configuration. So right underneath Captive Portal, I'm going to highlight all of this code, and we'll scroll all the way to the bottom. I'm going to highlight all of that. I'm going to copy that with Command C. I'll head back over to our test.yaml. I'm going to paste this into this page here right underneath the captive portal. And then, so we're going to take a quick run through this code to see what it does. So right off the top, we've got ESPHome and the name of the device is test, ESP8266, and the board is an ESP011M. We're enabling logging and we're enabling the Home Assistant API. We've got an encryption key here, and we're going to need this encryption key a bit later, so I'm just going to copy that to our clipboard here as well with Command C. We have an over-the-air password, and that allows us to do over-the-air updates. And we've got our Wi-Fi SSID referring back to the secrets file, and our Wi-Fi password referring back to the secrets file that we set up before. We're enabling a fallback hotspot or a captive portal in case our Wi-Fi connection fails. So if our Wi-Fi connection fails for whatever reason, it's going to create an SSID with this name, test fallback hotspot, and this password. And the captive portal enable there. So now we're into the actual configuration part of the YAML file here, the YAML configuration file. So we've got, we're creating a switch, we're using the GPIO platform, and we're switching on GPIO 0. The name at the moment is Heart Switch, and that's come straight from the configuration that we copied. I'm just going to change that to Test Switch, and that's just so that we can identify it later on. The signal here is inverted. So what that means is that when the switch is off, the GPIO pin is going to be high, and when the switch is on, the GPIO pin is going to be low. We can change this to false if we want to change that behavior, and that would depend on whether you want on to be on the normally open or the normally closed side of the relay. So if we were to change this to false, when the relay is energized, that should switch on the normally closed side of the relay. So I'm going to leave that at false. It says that the following can be omitted, and it says that the platform, we've got a switch platform of restart, and it's just going to be device name restart. So it will restart this device. So we're creating a switch to restart the device. We're also creating a sensor here, and we're creating a Wi-Fi signal sensor with the device name Wi-Fi signal, and our update interval is every 10 minutes. And we're also creating a human readable uptime sensor. So we've got a platform of uptime. Our name is device name uptime in days. Our ID is uptime sensor days. Our update interval is every 60 seconds. And then the configuration for that sensor. So we're looking at raw values. Every 60 seconds, we're publishing the uptime human, and we're using the state of the device. We're looking at a lambda of we're returning a string here of the days, hours, minutes, and seconds that the device has been online for. We're using a time domain to look at the Home Assistant platform and the Home Assistant time. So this is going to be helpful for the uptime to refer to. And we're creating a text sensor. We're exposing the ESP version as a sensor, as a text sensor. So we're showing the version number of ESPHome on the device, and we're showing the Wi-Fi IP and BSSID details on the device as well, and the human readable uptime, which it's pulling from this sensor that we've created up here. You can just copy paste this code and it will just work. We just need the line 29 down and it'll work. The line 27 and above, you don't need to change. Just remember to copy this encryption key field. And then when we've done that, we can save and we can install that. And we can install wirelessly, which requires the device to be online. We can plug it into the computer. We can plug it into the computer running the ESPHome dashboard, or we can download it and flash it manually to the device. I'm just going to click wirelessly, and that's going to then upload this configuration over to the device. Okay, so it's not really that obvious from here. It has uploaded the config and it's saying it's waiting for the result. It's trying to reconnect to the device in the background. We can just click stop on there. It's showing us offline, but if I refresh this page, it will probably come back up. Okay, so the ESPHome device has come back up. I did need to unplug it and plug it back in, but we see that it is now online. If we head back over now to our demo instance of Home Assistant, we can go to Settings, Devices and Services, and if we scroll through here, we'll see in the Discovered section here, we've got Test ESPHome. If I hit Configure on that, it's asking for the connection settings. We'll click Submit, and it's asking for that encryption key. We can paste the encryption key that we copied from the config before, and we'll click Submit, and it's found the following device, ESP011M Espressive. We'll just add that to the, we'll call that water closet for now, and we'll click Finish. So now that we've got that test ESPHome connected, if we click on one device here, we'll see all the details of the device. And so we've got the sensor that we created, the human readable uptime, and that's showing 55 seconds. We've got the configuration. We've got a switch here that we created to restart the device, and we can switch that on and it'll restart. We've got our BSSID, our IP address, and we've also got the firmware version, so 2022.6.3. And it was installed on the 13th of August at 4:01 and 30 seconds. So if we look at the controls here for the device, it's really just a switch. All we've done is created our own smart switch, but we can turn that on and you'll hear the relay click quite loudly there. And you might see there that there's a red light that's come on. I'll grab my mic and I'll put that close to the relay so you can hear that click. So that's off now. I'll turn it on again and off and on again. So it's pretty responsive. There's not a lot of latency to speak of. It works really quite well. So to give you a bit more of a real world demonstration of how this works, I've already created this one for the Millennium Falcon behind me. So on my production instance, I'll head to my everything dashboard and we've got the Millennium Falcon switch here. And we can turn it off and it turns off. We'll turn it back on and it turns on. So here on the B camera, what we've got is a unit that I'm using for the Millennium Falcon. The difference that you'll see here is that I've got this red wire looped out of the 5-volt positive side into the common side, and then I've got the red wire for the load coming out of the relay there. The ground wire for the load and for the supply are just bonded together inside this connector here. So all we're actually doing is switching the positive side of the load using the relay. So that's an introduction to ESPHome with the ESP01S relay board. As you can see, ESPHome gives us the opportunity to control ESP8266 and ESP32 boards, and these can be pre-built products like light switches or light bulbs, or in DIY projects like what we've got here. Let me know in the comment section down below what you think of ESPHome and how you're thinking of using it in your smart home. Or if you've got ideas for ESP projects you'd like to see in future videos, and if they're viable, I'll take a look at doing them. That's all we have for this video, and I do hope that it's helped you out in your home automation journey. Be sure to drop a comment down below with home automation ideas that you'd like to see me cover in a future video. Don't forget to also follow HiveMind Automation on Twitter, Instagram, and Facebook. If you like this video, hit that thumbs up button down below to drop a like. And if you're not already subscribed, please consider changing that now. While you're at it, if you hit the bell icon, you'll get notified when I release new videos each week. If you like what I'm doing here and you want to help to support the channel and you are in the market for a VPN provider, there is an affiliate link down below for NordVPN. I chose to partner with NordVPN because they have the best infrastructure of any of the VPN providers I looked into. They have a strict no logs policy and servers all over the globe. On top of that, they have apps for just about every platform, including Windows, Mac, Linux, iOS, and Android. So no matter what platform you're using, you can protect your sensitive personal information while you browse the web, even on unsecured Wi-Fi. So get a VPN today and use my link below to sign up for NordVPN. Lastly, if you want to support the channel directly, there is a Buy Me a Coffee link in the video description as well. Contributions that you make through Buy Me a Coffee are put towards making more and better content for you to enjoy. Thank you so much for watching. I'm Stu from HiveMind Automation, and I'm looking forward to seeing you next time. Bye for now.